Few spacecraft stir as much mystery as the X-37B, America's secretive spaceplane. Officially, it's an experimental test vehicle, but its missions fuel speculation worldwide.
The newest twist? Reports suggest it's now testing quantum navigation systems.
Quantum navigation could allow spacecraft to move without relying on GPS.
If true, this marks a leap forward in space autonomy.
The X-37B has been in orbit for years at a time, vanishing from public view. Each mission raises the same question: what exactly is it doing up there?
Traditionally, satellites depend on GPS to know their position.
But in war, GPS signals can be jammed or spoofed, leaving spacecraft blind. Enter quantum navigation, measuring the tiniest quantum effects to know location precisely.
This technology could free spacecraft from Earth-based systems entirely. Imagine a plane, ship, or drone moving flawlessly with no GPS at all.
Quantum sensors rely on the strange rules of atomic physics. Ultra-cold atoms are trapped in lasers, measuring tiny changes in movement.
In theory, this could track a spacecraft even at the edge of the solar system.
For the X-37B, this could mean unprecedented stealth in orbit.
While rivals scan the skies, quantum navigation could keep it hidden.
This is not just science fiction. Labs have already tested prototypes on Earth.
The challenge is miniaturizing them for spaceflight.
If the X-37B carries such a system, it could reshape space warfare. If the X-37B carries such a system, it could reshape space warfare.
Future Mars missions could navigate precisely without GPS.
Deep space probes might chart courses with unmatched accuracy. But secrecy around X-37B means the public may never know.
Each landing fuels speculation about hidden experiments.
Is it testing new engines, surveillance tools, or advanced navigation? Quantum navigation fits perfectly into this pattern of mystery. Rival nations are also investing heavily in this frontier. China and Europe are racing to master quantum inertial navigation. Whoever achieves it first could gain a decisive advantage in space. The X-37B's latest mission reportedly lasted more than 900 days. During that time, it may have quietly tested new technologies. NASA and the Pentagon rarely reveal details of its payloads. But observers note patterns that hint at advanced experiments. Quantum navigation, if confirmed, is the most groundbreaking yet. Imagine a fleet of craft navigating independently across the solar system. No reliance on satellites, no signals to intercept. That autonomy could redefine both exploration and warfare. For now, the X-37B remains silent in the night sky. But its missions remind us the future of space may already be here.
The X-37B is operated by the U.S. Space Force, though details remain classified.
Official statements describe it as a technology demonstrator. Yet every mission extends longer, fueling curiosity. The fifth flight lasted nearly 2.5 years. Quantum navigation might explain why it can stay hidden so well. Traditional radar may miss a craft navigating this precisely.
Inertial navigation once filled this role, but drifts over time.
Quantum sensors aim to eliminate that drift entirely. The physics are exotic, but the implications are very real. If the US perfects it first, space dominance could shift overnight.
China has tested its own experimental quantum sensors on Earth.
Europe, too, is funding major research in this field.
These efforts highlight a global race for navigation supremacy.
Whoever achieves reliable, space-ready quantum navigation first wins. The X-37B's secret cargo bays may already hold such experiments. The X-37B's secret cargo bays may already hold such experiments. Could it be new propulsion, energy weapons, or navigation systems? Quantum navigation fits all the clues. Imagine a spacecraft moving silently, impossible to jam. This could change not just orbits, but the balance of power. Civilian uses are equally transformative. Deep space missions could navigate with no Earth contact. Ocean-going ships on Earth might one day use the same tech. Aircraft, too, could fly without satellites. But for now, the focus remains firmly in space. The X-37B looks like a miniature space shuttle. It launches atop a rocket, but lands like a plane. This hybrid design makes it flexible and reusable. Add quantum navigation, and it becomes even more versatile. Suddenly, stealth missions lasting years make perfect sense. Each return to Earth brings valuable data back. Engineers carefully analyze its payloads in secure labs. Officially, these are technology maturation experiments. Unofficially, they may be shaping the future of navigation. Quantum navigation works by tracking atomic interference patterns. These patterns reveal exact position and movement. It's like having an internal compass, but quantum precise. For military craft, that precision could be a game changer. For explorers, it means traveling farther, faster, safer. And for the X-37B, it means one thing: mystery deepens. Each mission of the X-37B pushes the limits further.
Longer flights mean more advanced experiments.
Some believe it's a platform for next-gen weapons. Officially, this remains unconfirmed speculation. Calm, engaging narration. Navigation experiments are the most plausible guess. Quantum sensors do not rely on external signals. That makes them immune to GPS jamming.
It's like giving the spacecraft an internal map of space. For military planners, this changes everything.
Civilian airliners could one day adopt the same tech. Submarines could navigate silently under oceans.
Even Mars missions could travel with total autonomy.
Public images only show its shuttle-like shape.
What lies inside remains unknown.
Could the real breakthrough already be flying?
Quantum navigation in active spaceflight would be revolutionary. Navigation without satellites saves billions. It also removes vulnerability to attacks on orbiting satellites.
In any conflict, that advantage could be decisive.
Quantum navigation uses ultra-cold atoms as sensors. These atoms act like precise rulers in space. Each vibration encodes location data. The result is unmatched precision. Combine this with the X-37B's stealth design, and you have a craft nearly impossible to track. This is why many believe it's more than a test platform. It may already be a prototype for future fleets. Reports say 2 craft might fly simultaneously. Calm, engaging narration. Coordinated, stealthy, quantum-guided fleets. This raises big questions about transparency. Should such missions remain entirely secret? Or should humanity know if quantum tech is already in space?
the stakes are nothing less than control of the orbital frontier.
Still, space exploration often spins off civilian tech.
GPS itself began as a military program.
Today, billions rely on it daily.
Quantum navigation might follow the same path.
Which makes the X-37B's flights not just military tests,
But perhaps glimpses of the future of space itself.